Hello everyone, today me Nurul Natasha binti Lausiwa and my group mate Susmita Anrat binti Jasmine and Lee Chi Eun will be presenting about cadmium iodide. So, what is cadmium iodide? Cadmium iodide is an inorganic compound with the formula of CdI2. It is a white hygroscopic solid and it can be obtained as a mono and tetrahydrate. Unit cell and lattice type of cadmium iodide. These are a large continuous repeating unit hexagonal cell of cadmium iodide compound, where the green circle represent iodide ion and the purple circle represent cadmium ion. And based on this large continuous repeating unit, we can zoom into a one unit cell. What are unit cell? Unit cell is the smallest repeating unit which show the symmetry of the crystal structure. The unit cell of cadmium iodide is hexagonal cell. Based on the diagram below, it shows that the length of A is equal to the length of B, but length of C is longer compared to A and B. The angle of alpha and beta is 90 degrees, which is perpendicular to each other, while gamma is 120 degrees. Cadmium iodide is normally a very similar structure to rutile. It is a hexagonal lattice type derived from HCP and ion array with half of the octahedral site occupied by cadmium ion. To be more specific, the cadmium ion occupied the every octahedral hole between this layer, which is the purple layer, and the iodide ion occupied the hexagonal closed packed lattice, which is the green colored layer. So next, where is the location of each atom and ion? As we can see, this is a one unit cell of hexagonal, and the 8 corner that I circle represent the iodide ion. Additional to that, there is one more iodide ion at the center of the unit cell, specifically at the coordinates of 2/3, 1/3, and 1/2. As for the cadmium ion, there is only one located at the center of this unit cell, specifically at the coordinates of 1/3, 2/3, and 3/4. This location, cadmium ion, is also known as octahedral hole of the HCP. For your information, there are 2 octahedral holes in the hexagonal unit cell. However, for the case of cadmium iodide, only half of the octahedral hole will be occupied by the cadmium ion.
Do you know what is the unit formula for cadmium iodide? To know the unit formula for cadmium iodide, you need to know what its unit formula is. Unit formula is the number of ion or atom which found in a single unit cell. So, to calculate the unit formula, you need to know what is the contributions of lattice point in atom or ion at different positions. For example, corner 1/8, center 1, face 1/2, edge 1/4. So the picture here shows the unit cell of the structure of cadmium iodide. Solid green show the iodide ion, while the small purple solid show the cadmium cation. So from this structure, we can see that there are 8 iodide ion at the corners and 1 iodide at the center of hexagonal cell. So the unit formula for iodide is 2. While for the cadmium ion, there is only 1 cadmium ion that occupies the half of octahedral side of the hexagonal cell. Thus, the unit formula for the cadmium ion is 1. After calculating the number of unit formula for iodide ion and cadmium ion that are 2 and 1 respectively, therefore from here we know that the unit formula of cadmium iodide is 1.
Moving on, we'll be explaining on the coordination number of cadmium iodide. What is a coordination number in solid-state chemistry? Coordination number is the number of atoms that are the nearest to an atom in the crystalline structure. The coordination number of cadmium-2 ion is 6, and the coordination number of iodide ion is 3. The structure below shows the AB-AB stacking arrangement of an ion, which is iodide ions with the cadmium-2 ions occupying half of the octahedral sites in alternate layer. The purple spheres represent cadmium-2 ions, while the green spheres represent iodide ions. Let's focus on the highlighted cadmium-2 ion. You can see that the cadmium-2 ion is bonded to 6 iodide ions, which are 3 at the top and the other 3 at the bottom. Moving on to the iodide ion, you can see that it is only bonded to 3 cadmium ions, as the cadmium ions only occupy half of the octahedral sites and in alternate layer. Next, the physical and chemical properties of cadmium iodide. The physical properties of cadmium iodide is it is a white odorless solid and might turn yellow when it is in contact with the air. The melting point and boiling point of cadmium iodide are 388 degrees Celsius and 787 degrees Celsius respectively. Cadmium iodide is non-flammable. The chemical properties of cadmium iodide is it has a pH of 5. It is very soluble in water and soluble in organic solvents. It is also chemically stable under normal conditions.
Do you want to know what are some applications of cadmium iodide? Firstly, cadmium iodide is very useful in electroplating. For example, in the aerospace industry, steel components of aircraft are often electroplated with cadmium to enhance their resistance to corrosions. This not only extends the lifespan of this component but also ensure the safety and reliability of the aircraft. This is because cadmium iodide crystallizes in a layered structure that has the hexagonal cross-pack arrangement. In this structure, cadmium ions are located at whole of octahedral site, and iodide ions form a hexagonal cross-pack framework around the cadmium ions. This layered arrangement allows for easy dissociations of cadmium and iodide ions in solution, providing a consistent supply of cadmium ions during electroplating. Next, the cadmium iodide also used in the photovoltaic. Cadmium iodide is often used in thin-film solar cells due to its ability to efficiently absorb and convert sunlight into electricity. This is because the layered structure of cadmium iodide can facilitate the formations of heterojunction with other materials. Heterojunction are the interface between two different semiconductor materials that can create an electric field to separate the charge carrier efficiently, thereby enhancing the overall efficiency of the solar cell. Cadmium iodide has a band gap that is very suitable for absorbing the sunlight. The band gap of material is the energy difference between the valence band and the conduction band. A suitable band gap allows the cadmium iodide to absorb a significant portion of the solar spectrum, which is crucial for converting sunlight into electricity. Lastly, cadmium iodide is very useful in digital radiography. Cadmium iodide-based detector can be used in digital radiography system where they provide high resolution and high sensitivity image. The ability to directly convert X-ray to electrical signal allows for faster image acquisition and processing, which is beneficial in medical diagnostic. This is because cadmium and iodide both have relatively high atomic number, which are 48 and 53 respectively. Materials with high atomic number are more effective at absorbing X-ray because they have a greater probability of interacting with high-energy photons through processes like the photoelectric effect. Cadmium iodide has a wide band gap and has a layered structure which is very beneficial for X-ray detectors. A wide band gap reduces a thermal noise, allowing the detector to operate effectively at room temperature without significant loss of signal quality. This is crucial for achieving high resolution and sensitivity in X-ray imaging. Thank you for listening. Hope you learned something from our video. Bye!